Okay, so today we're going to talk about solving inequalities algebraically and graphically. Okay, so solving absolute values inequalities. Okay, so there's a purple box there. Go ahead and read that for me. Okay, are there any questions on that purple box? And that purple box is kind of hazy a little bit, so let's go ahead and actually jump into the example and see what we find here. So let's go ahead and see if we can solve that the absolute value of x minus 4 is less than 8. So to solve that, we would go ahead and let's do it graphically first. If I graphed this, okay, the graph is going to look like this, and I'm going to have 4, because I'm moving it to the right, it's x minus 4. And it's going to look like this. So this is what the graph is. This is what the graph of x is, y is equal to, this is y is equal to the absolute value of x minus 4. Okay. Now I'm comparing this to 8. So 8 is right here. And this is 8. So this is y is equal to 8. So I need to find where the graph of this is less than 8. So where would that be? That would be from here. So it has to be under the red line, right? Under the red line. It's under the red line from here to here. So it would be from here to here, right? Anybody know why I have these open dots instead of closed dots?
It's not equal to.
Yeah, because it's not equal to, right? It's greater, it's less than. There's no equal sign there. So it does not include here, right? So if I took and looked at my graphing calculator, I'm going to find out where these 2 points are, and I can go ahead and say that's the answer. So that's how I would run this graphically. Okay. Algebraically, when I say that the absolute value has to be between 8, I don't know, has to be smaller than 8 or less than 8, that means that what that really means is that x minus 4 is between 8 and minus 8, right? Because it has to be between here to have an absolute value that is smaller than 8, right? Now I just go ahead and add 4 on everything. It would be negative 4x 12. Okay, so this would be my answer, negative 4 to 12. So obviously this is negative 4, and this here is 12. Okay, did everybody see that? Do we understand what we're looking at here when we're solving it graphically? We're looking at the portion where the graph of this guy is underneath or less than 8. Okay, all right. If I go ahead and change this question and go like this, now what are we looking at? We're looking at when the absolute value or this curve, this graph is greater than 8, so it's above here. So it'd be x has to be greater than 12 or x is less than 4. Less than negative 4, I'm sorry, negative 4, right? Okay, everybody see the difference there? Okay, example number 2. Solving the other one. So let's do example number 2. Okay, so let's see if we can do this algebraically. Algebraically, we have 3x minus 2. This is example number 2. 3x minus 2 greater than or equal to 5. Okay. Right, so in other words, what do I have here? I have that 3x minus 2 has to be greater than 5, or 3x minus 2 has to be less than or equal to negative 5, right? Because if it's less than negative 5, it would be like negative 5, negative 6, negative 10, negative 20, and the absolute value of that would be greater than 5. Okay, so I have two separate inequalities to solve here. I'm going to add 2 on both sides. So I'm going to be 3x is greater than or equal to 7, which means that x is greater than or equal to 7 over 3. Or 3x minus 2, I'm going to again add 2 on both sides. Less than or equal to, I get negative 3. No. So I'm going to go ahead and add the 2 already. I added the 2 to get rid of this 2. I added the 2 over here to negative 5 to become negative 3. So x is going to be less than or equal to negative 1. So this is your answer right here. Your answer is this or that. Right? Okay, so that's that. Solving quadratic equations. So solving a quadratic inequality, okay? Solving a quadratic inequality. Let's go ahead, just jump right into the examples. So solving the quadratic inequalities is nothing different than solving a quadratic equation. You just have to worry about the inequality part. So here we go. We have x squared minus x minus 12 is greater than 0? Greater than 0?
Mr. On.
Yeah.
Lila's in the waiting room.
Okay, thank you. Lila and Ezekiel are waiting. Yeah. All right, so example number 3. X squared minus x minus 12 is greater than 0. So if I were to take this and I need to factor it, if I factor it, what do I get? Is this factorable? Are there two numbers that are multiply to negative 12 and add to negative 1?
Yes.
Okay, so they would be what?
X minus 4 and x plus 3.
X minus 4 and x plus 3, right? So I have plus 3, negative 4 adds to negative 1. So this is going to be x minus 4, x plus 3 is greater than 0. Okay? So how does this work? At this point, what I would do is I would go ahead and just draw this. Okay, so what are the roots here? It's either 4 or negative 3, right? Either 4 or negative 3. So I'm going to go ahead and draw it and say 4, negative 3. This is what the graph looks like. How do I know it's a smiley face? Anybody want to tell me that? Why I know that?
Bigger.
Huh?
It's bigger than 0.
Nope.
No?
That's not why it's a smiley face. Why is it a smiley face?
Because it's less than 0?
No, because this guy here is 1, right? It's positive, right? You have a
Oh.
1.
Oh,
Right? In other words, the a of ax squared plus bx plus c, the a value is positive. That's why it's a smiley face. Remember we talked about this, right? So
yeah.
now that I've drawn this, and I know it goes through negative 3 and 4, because those are the points right here. Okay, I know it goes through these points here, okay? It is greater than 0. So they want the part where the quadratic equation is greater than 0. So it would be, again, because there's no equality, this would be an open dot. And it would be on this side, right? This is where it would be greater than 0. And again, open dot over on this side, right? Can you see how that gets filled in there? Because the y value has to be greater than 0, right? Greater than 0. greater than 0. It's greater than 0 when x is greater than 4 or x is less than -3. Are we good with that? Again, if I change the problem and I said I wanted you to solve for this, how to change the answer? Now I'm looking for the portion of this quadratic graph where it's less than 0, right? Where does that happen? It's going to happen down here, right? -3 and 4. Does everybody see how by changing that my answer changes? Are we good there? Okay, let's see if we can do another one. Example number 4. Example number 4. We want to solve 2x squared plus 3x is less than or equal to 20. Okay, so the very first thing I'm going to move the 20 over. 2x squared plus 3x minus 20, 0. Okay, so I'm going to have to play around here to see if I can find something. See if I can factor this out. Okay, now the trick here is that you have a 2, so you're going to have a 2 and a 1 like this. Okay, and over here, you're going to have something where it multiplies to -20. And when I cross and cross, I'm going to have +3. Okay.
8 and -5.
It'll be 8 and -5. So in other words, to get the 8, you're going to have to get the 4 over here, right? You're going to have to get the 5, -5 this way. So it'd be +8, -5, which ends up being +3. Okay. So in other words, this becomes 2x minus 5, x plus 4 is less than or equal to 0. Okay. So let's say that you weren't able to get that. Okay, let's say you were not able to see this, okay, which is not uncommon, okay. So I don't know, if I can't get this, what do I do? Am I done? Do I give up? What do I do? Okay, if I don't get this, what am I doing? I'm going to put him in the quadratic equation, right? To find out what the roots are. So I put it in the quadratic equation. -b plus or minus square root of b squared minus 4 times a times c over 2 times a. Right? So I'm going to get -3 plus or minus square root of 9 minus minus, they cancel out to become plus. I have 2 times 4 is 8. 8 times 20 is 160 divided by 4 minus 3 plus or minus, what is the square root of 169?
13.
13 over 4. So when it's plus, I get -3 plus 13, which is 10 divided by 4. 10 divided by 4. When it's negative, I get -3 minus 13. So I get -16 divided by 4. -4, which are these two answers up here, right? -4, 5 over 2. So I get to the same conclusion, okay? But I do have to do a little bit of work. By not being able to factor it, I just go ahead and toss it into the quadratic equation, and it still works out. Okay? All right? So just because you can't factor something doesn't mean you give up. All right? Okay, so here we are. So we found two separate ways, we found the same answer. Okay, again, is this a smiley face or a sad face? What if I draw the graph?
Smile ones.
The smiley face, again, because 2 is positive, correct?
Yeah, goes up.
I'm gonna have 5/2, -4, and I want to know when it's less than or equal to 0. Less than or equal to 0. So it's going to be from here. Now it's a closed dot. These are both closed dots because I have the equal sign. And it's going to be down here. So your answer is -4x 5/2. Okay? And that's how you would work that. Okay, if I want to do this graphically, how would I do this? That would be the easiest way, right? How would I graph it? I would just toss this in my calculator and boom, I'll get this, right? And I just figure out when it's less than 0. Okay, so graphically it's pretty easy. Okay, let's do example number 6. Okay, example number 6. Showing, okay, so solve, it says solve x squared plus 2x plus 2 is less than 0. Okay. So does this factor out? Can I factor this? Doesn't look like it. There aren't any numbers that multiply the 2 and add the 2. Okay, so what do? I put it in the quadratic equation. -2 plus or minus square root of b squared 4 minus 4 times a times c over 2 times a. Okay, so what do I get? I get -2 plus or minus square root of 4 times 2 is 8. 4 minus 8 is -4 over 2. So it's going to be -2 plus or minus 2i over 2, -1 plus or minus I. So I have this I thing. What does that mean? What does it mean that I get an I?
It's
Square root
like
-1.
It means that there are no real solutions, correct? Remember we said that if the discriminant, which is b squared minus 4ac, if this is less than 0, we said there was no solutions, correct?
Yeah.
Right? So there are no solutions, which means that if you actually drew this graph, the graph's going to look like this. The graph's going to look like it's going to ride high above the x-axis. So it never
6 plus 2.
And so it never meets, right? So it's always positive, which means what? What's my solution here? When is it going to be less than 0? Never, right? Never. It's never going to be less than 0. Therefore, the solution is no solution. Okay. If you look at this a little closer, you might have been able to say or see this as x squared plus 2x plus 1 plus 1, right? And what is this part here? What is this? X plus 1 squared plus 1, right? Which means that this always has to be greater than 0 because it's a squared value. So if this is always going to be greater than 0, and you're going to add 1 on top of that, right? That means that this is always going to be greater than 1, at least 1, because the smallest this guy can ever be is 0, right? So this value here, or this value, is always going to be greater than 1. So it's never going to be less than 0. Does that make sense? That's more of a different kind of approach, right? Okay, so we'll stop right here. And we'll see if we can work on the homework. Are there any questions about what we have talked about so far?